How does one name become synonymous with genius? When you hear the word, you probably picture a man with wild hair, a playful twinkle in his eye, and maybe a tongue sticking out. That's right, we're talking about Albert Einstein. But who was the man behind the iconic image? How did a patent clerk from Germany revolutionize our understanding of the entire universe? Today, we're going on a journey through time and space to uncover the story of Albert Einstein and his monumental achievement, the theory of relativity. Get ready, because we're about to bend the fabric of space-time itself. Born in 1879 in UMU, Germany, young Albert wasn't exactly the prodigy you might expect. He was a late talker, and his teachers often found him rebellious and uninspired. He disliked the rigid rote-learning style of his school. But in his own world, he was deeply curious. A pivotal moment came when his father showed him a simple pocket compass. The 5-year-old Einstein was mesmerized. What invisible force was making that needle point north? This single question sparked a lifelong fascination with the unseen forces that govern our world. He taught himself advanced mathematics and physics, often far ahead of his school curriculum. He wasn't a poor student. He was just bored by a system that couldn't keep up with his own mind. After graduating, Einstein struggled to find an academic position. He eventually landed a job as a patent clerk in Bern, Switzerland. This seemingly mundane job turned out to be a blessing in disguise. The work wasn't too demanding, leaving him ample time to ponder the deep questions of physics that had captivated him since childhood. He would analyze patent applications for electromagnetic devices, and in his spare time, he would conduct his own thought experiments, his famous Gedankenexperiments. It was during this period, 1905, that Einstein had what is now called his miracle year. At just 26 years old, working in relative obscurity, published 4 groundbreaking papers that would forever change the course of science. One paper explained the photoelectric effect, for which he would later win the Nobel Prize. Another proved the existence of atoms. But the most famous of these papers introduced the world to the special theory of relativity. Einstein started with 2 simple but revolutionary ideas. First, the laws of physics are the same for everyone, as long as you're moving at a constant speed. Second, the speed of light in a vacuum is constant, no matter who measures it or how fast they're moving. These ideas seem straightforward, but their consequences are mind-bending. To make these 2 principles work together, Einstein had to throw out our everyday understanding of space and time. He realized they weren't separate and absolute, as Newton had thought for centuries. Instead, they are interwoven into a single continuum, space-time. And this space-time is not fixed. It's relative. It can stretch and shrink depending on your motion. This leads to some strange effects. For example, the faster you move through space, the slower you move through time relative to a stationary observer. This is called time dilation. It means a clock on a fast-moving spaceship would tick slower than a clock on Earth. It's not a trick. Time itself is actually passing more slowly for the astronaut. It's a real measurable effect. From this theory came the most famous equation in all of science, E equals mc squared. E equals mc, energy equals mass times the speed of light squared. This simple formula reveals a profound and powerful truth about the universe. Mass and energy are 2 sides of the same coin. They are interchangeable. A tiny amount of mass can be converted into an enormous amount of energy, because the speed of light squared, that c² part, is a huge number. This equation explains how the sun shines and is the fundamental principle behind nuclear energy and, unfortunately, nuclear weapons. In just 5 characters, Einstein unlocked one of the deepest secrets of the cosmos. But Einstein wasn't done yet. The special theory of relativity was fantastic, but it only dealt with constant motion. What about acceleration? What about gravity? For the next 10 years, Einstein wrestled with this problem. He described it as the most intense period of intellectual struggle in his life. He imagined a person in an elevator. If the elevator is in deep space and accelerating upwards, the person feels a force pulling them to the floor, just like gravity. Now, imagine the elevator is stationary on Earth. The person feels the same pull of gravity. Einstein's brilliant insight was that there is no experiment you could do inside that sealed elevator to tell the difference. He called this the principle of equivalence. Gravity and acceleration are indistinguishable. This led him to an even more radical conclusion. Gravity isn't a force pulling objects together as Newton had proposed. Instead, gravity is a consequence of the curvature of space-time. Think of space-time as a giant, stretched-out rubber sheet. If you place a heavy object, like a bowling ball, in the middle, it creates a dent, a curve, in the sheet. If you roll a smaller marble nearby, it won't be pulled toward the bowling ball by a mysterious force. Instead, it will simply follow the curve in the sheet created by the bowling ball's mass. That's gravity. Massive objects like planets and stars warp the space-time around them, and other objects simply follow these curves. As the physicist John Wheeler famously put it, space-time tells matter how to move. Matter tells space-time how to curve. In 1915, Einstein finally published his masterpiece, the General Theory of Relativity. This new theory of gravity made several predictions that could be tested. One was that gravity could bend light. This was a radical idea. How could gravity affect light if light has no mass? But in Einstein's theory, light simply follows the curved path of space-time. In 1919, during a solar eclipse, the astronomer Sir Arthur Eddington conducted an experiment to test this. He observed starlight passing near the sun, and just as Einstein predicted, the sun's immense gravity bent the light, making the stars appear in a slightly different position in the sky. When the results were announced, Einstein became an overnight global superstar. Newspapers around the world heralded a new understanding of the universe. The theory of relativity has been tested and confirmed countless times since. It's not just some abstract theory. It has practical applications you use every day. Your phone's GPS, for example, wouldn't work without it. Satellites in orbit move at high speeds and are in a weaker gravitational field than we are on the surface. This means their clocks tick at a slightly different rate than ours. Both special and general relativity are needed to correct for these tiny time differences. Without these corrections, your GPS would be off by several miles within a single day. From black holes to the Big Bang, gravitational waves to the expansion of the universe, Einstein's theories form the very bedrock of modern cosmology. Einstein's life story is as compelling as his science. He was a pacifist who fled Nazi Germany, a humanitarian who championed civil rights, and a humble man who never lost his sense of wonder. He showed us that the universe is far stranger and more beautiful than we could have ever imagined. He taught us to question everything, to follow our curiosity, and to never stop marveling at the mystery of it all. His legacy isn't just an equation, it's a new way of seeing the world. Thank you so much for joining me on this journey through the life and mind of Albert Einstein. If you enjoyed this deep dive into science and history, please hit that like button and subscribe for more stories about the brilliant minds that shaped our world. Let me know in the comments what other scientific giant you'd like to learn about next. Thanks for watching.